Hello and welcome to Beep Boop Electronics Workshop. If you're watching this, you've probably bought one of our kits, and I want to say thank you for that. Today I'll be showing you how to put that kit together and just explaining a little bit behind, what it is, what it does, and how it works. So yeah, let's get started. If I open up the kit, got a few little packages. A manual for later, and a bill of materials. So whenever I get a kit, first thing I'll do is just make sure I've got everything. I wouldn't get it all out, but just a little quick look. Yeah, PCB, panel, jack, switches, miscellaneous. Right, so it's all there. So to get the first step would be we want to get our PCB and panel out. Cool. And yeah, if you take a look at the PCB, it's got two sides. On one side we've got lots of pictures of kind of where the control components go, and then on the back where all these passive components go, and we can put the panel just to one side for now. So if you like me, you might not read the manual and you might just crack on. For anyone who wants a really clear step-by-step guide, there's a QR code on the back of the kit. Just follow that and should give you a really easy step-by-step guide. But I'm going to just go at it as I would, same way I kind of documented it. The first thing I want to populate is this resistor here. So let's open up the resistor. A pair of scissors probably be handy. You can just make sure there's nothing at the end there. Okay. So there's one 1K resistor. Take that, straighten it out, bend it over as close as you can to the body of the resistor, and put that in place. Different people have different approaches. I've always been the kind of person who likes to bend the leads over because it meant I could populate big boards and then cut them all later. But as this is a build guide, I'll show you as we go along. Whenever I go to solder, I normally cut just at the edge there. See if you can see. Be careful when you're snipping leads. It's the last thing we actually want in a repair workshop is leads flying everywhere, but I'll get these later. And you see there, I don't know how clear this is, first time I've made a video in a long time, just at the edge of the solder pads. And the next step is to populate these two polybox ceramic capacitors. We've got two values. One is 15 NF, the other one's 100 NF. Should be quite clear. I think I've written on the bit of cardboard, yeah, somewhere over here, just to say what it is, and then by deduction the other one's the 100. So start off with the 15 NF, which, if I double check my build guide, goes through C1. Again, fold over the legs, and then take the 100 and put that in C2. And I'll cut these off quickly. So you might be wondering, I always like to think when I'm building a kit, what are these components? Why are they going where they are? If you ever don't know what something is when you're putting it into a board, have a look online, type it in. I've put part numbers next to most of these, so have a look, see what it is, and the internet's a wonderful place to find out. So once I've got those in place, I like to now solder them on. This is probably the handiest thing, most used thing in my workshop, strangely enough. Just a cardboard tube, but it's just great for soldering. I find anything fits there, and you know, it's nice to reuse these things rather than throw them away. So I've turned on my iron. I get it up to about 390 degrees. Different people, you know, will vary their temperature depending on how quickly they solder or what kind of solder they're using. I'm using leaded solder just because that's my preference. I don't advise anybody else use it. I'd recommend you use unleaded, but the nice thing about this stuff is it just flows really quickly and easily, and less likely we're going to have any problems. So yeah, I should probably talk you a little bit through, if you haven't soldered before. There's loads of tutorials online. My approach is, yeah, get the iron up to about 390, hold the tip of the iron on for about 6 seconds, tap it just to see if it flows, put a little bit in, 1, 2, let it flow, and then maybe another little tap, re-tap, and then go over it. Yeah, and that's all we're looking for, really. Same with the others. If you have a choice out of them, you know, you might see that there's one's ground and one's the other. Grounds take a little bit longer, just be aware of that. So 1, 2, 3, 4, 5, 6. Tap it, a little bit in, 1, 2. It's quite funny doing this and talking. I'm normally not really aware of what I'm, just in the flow of it. 1, 2, 3, 4, 5, 6. And then move on to the ground side. 2, 3, 4, 5, 6. Little tap, you see it didn't go. 7, 8, then it does. Now that kind of effect, if you're working on really big boards, it does make a massive difference. So little tip for anyone working on bigger projects, leave the ground pins till last. Okay, so they're all nicely soldered in. Don't worry too much about these, you know, they don't have to be completely flush, but it might be worth just giving that a little trim, and then reflow them once more just to get the leads a bit flusher to the board. Okay, on to the next step. So I think the next thing on the build guide was the Vactrol, the main component really in this kit. So what is a Vactrol? So a Vactrol's really, it's a component made of 2 other components. Inside it you've got a LED, and then you've got a light dependent resistor or photoresistor, which changes its resistance between these 2 leads depending on how bright the LED is, or the intensity of light. So there's lots of different types of Vactrols. You might see loads of different types of numbers, and it's worth having a read of the data sheets and just seeing how those numbers change really the properties of these Vactrols. They're, you know, as I said at the beginning, they're non-linear, and that's really why we use them. They've got this characteristic kind of decay, which sounds quite natural, and then there's almost like this, I guess, overtones that get added, you know, this kind of ringing or buzzing, which is kind of nice. Anyway, yeah, so there's a few different companies that make these. X-Clive, you know, being the main one, but I think that's how you pronounce it. But these ones I was able to get quite cheaply straight from China, and when I tested them against the X-Clive ones, I actually really prefer these. The other ones sounded a lot darker, whereas these sound quite bright, and they have a really good dark resistance. Anyway, I could go on about stuff like that all day. As you see, it's got 4 leads. The 2 shorter ones are the LED, and the shortest one of those is the cathode, the negative terminal of the LED, and the longer one being the positive. So that might look a bit reminiscent now. The cathode goes top right or into the square hole. Just do that to size it up, and then we'll bend these down. Okay. Perfect, in place, and you can just double check that that's right. You should be able to see the writing. It should say STVTL, and the writing should be, yeah, facing down. Oh, get that in shot, sorry, I'm not very good with this. There we are, I think like that, yep. So, now bend the leads. I like to kind of bend them away from each other to make it really easy. Again, cut just on the edge. Cut just on the edge of these pads. And let's go to solder that. So, 1, 2, 3, 4, 5, 6. Little tap. And a bit more to reflow. So I really recommend getting yourself a decent iron in the time I spent as a repair technician. The most common kind of thing that I saw with DIY builds that didn't work was just either buying really cheap NAF solder or using an iron that's, you know, way too hot or just can't get hot enough. So yeah, get yourself you know, something like a Heiko, or even these little USB TS100s straight from China are actually really good. Okay, so that's soldered up, and we'll now move on to, I think, yeah, let's put the jacks and the switch on and the slider. We go to the other bag now. Come on. I think I got it all. When I'm assembling stuff, it's worth thinking, well, what stays in the best? I think these are quite solid once they're in there. So this is a slide potentiometer. It's just like the knobs, but works vertically. And then it's got one pin on one side, so if you align that, and then the two at the top, pop that in, and then you want to press it. Have I got this in shot? Sorry. Go. Really get that, make sure that's on nice and flat. Yeah, if you want to be, it kind of stays on. I think in the build guide I suggested just put tack in one of these. There we are. And just to be 100% sure, sometimes if you just hold it and firmly grip whilst reflowing, you can just make sure 100% that that's nicely seated on the board. And now that's not going to go anywhere. Take the switch. We won't need these middle washers. We just want the two nuts. Screw that down to the bottom. Little point of detail, I like putting the flat side down because you can't see it then. Get the jacks, put them in place, and starting to look like a module. To get this all to hold together with the panel, I noticed that I could have mounted it with these. There's actually some little screws in these, but I didn't find it strong enough, especially for a little 2 HP design, so I've put a mounting at the top. If you open your other bag, open it up, there'll be a M2 2.5, I think it's 12mm standoff, and then you separate. Keep the black screw for the front panel because that looks smarter, but take your silvery one, And this is going to be a bit awkward, or maybe you should have done it the other way around, but anyway. Hold that on here. Don't know if that's in shot. Get this in shot. When there's a will, there's a way. Right, so now that's on there. To get the panel on really nice and flush, what I have included is a couple of washers just to put on these jacks, which makes them up pretty much perfectly to 12mm. So a pair of tweezers is always really handy for doing this, because it can be a bit of a fiddle, but there you go. He says, there you go. And the last one, there we go. So now they're in place, the panel should go on really nicely. And this will be a chance to just double check as well. Excuse me. This will be a chance to double check that you've got your slide pot on really nicely. That's all looking like it's sized up pretty well. Take your panel, front panel, black M2.5 6mm screw, and just hand tighten that into place. And now's a chance just to lock it all together with a jack nut. Right, that's on. Screw that up. Hand tight only at this point as well. If you go and start, getting a tool on that, what you'll end up doing is bending all these pins, and there's no need for it. Just that'll hold it all together really nice. And then the last stage before we start soldering again, just hand tighten that up into position, and then that should be nice. Oh, he said one more. Right, it's looking like a module, and yeah, checking that slider, I'm pretty happy with that. I don't think I'm going to get it any straighter. So, time to solder. If you're really finicky like me, excuse me, I bend these pins just a little bit in. And start with your slide potentiometer. Let's get this a bit better in shot. And you can do the mounting tabs as well. Sometimes I'll leave these, until I've tested a module, because it can be really annoying having to, desolder all of this. But I'm pretty confident. Yeah, I'm confident this should work. We'll just give that a little touch up. Was only a tack solder. That's the slider on. Only really tricky bit with this build is just getting into this switch, but recommend approaching it from the side like this, and then you should be able to get your iron to the pads. Right, that's the switch soldered. And lastly, we're going to solder all the jacks in place. Should really have my extractor fan on, but you wouldn't be able to hear me. So I'll just have to put up with it this time. I didn't really mention much of that at the beginning, but yeah, should do. Health and safety kind of stuff. Make sure you're in a well ventilated area. Wash your hands after doing this. Don't pick up the solder iron the wrong way around. That should cover me. Okay, so finish these grounding tabs at the side. Really important we solder these, because a signal obviously needs a reference. Solder them from the inside just to keep it nice and tidy. That way it looks nice and smart. And then the last three. If you're not happy with any of your soldering, or it's just not taking, take a step back from it for a little bit, take a breather, have a look, just make sure everything you're using's right. Is your iron getting up to temperature? Have you got a good tip on it? Are you using decent solder? Once all those things are in place, it should all come together nicely. So I'm really chuffed with that. Could turn off my iron now. All looks good to me. And the final step before we test is just pop the knob on. There we go. 2 HP low pass gate. So thanks for checking this out. Hope you enjoyed building it and using it, and yeah, if you make any videos, please post them and tag us, because we always like to see what people do with the stuff. Until next time, bye.